everyone, it's Miss Stewart, and today we're going to be doing notes on section 3.2, which is talking about K-selected species versus R-selected species. The learning objective for today is that you'll be able to identify differences between K and R-selected species. Some of the essential knowledge that we're going to gain is the differences between K-selected species and R-selected species, and the trends that we see in the parents, the offspring, the lifestyles, and we're going to talk about some of the benefits and problems for both of these different types of species and some of the things that can impact them, especially when it comes to situations like environmental change. So when we're talking about K-selected species versus R-selected species, this is basically identifying the different reproductive strategies that species can have. And we tend to think of it in the terms of quality versus quantity. Now, K-selected species are going to be the species that have the quality reproductive strategy. And the reason we say quality is because although they have few offspring, they give heavy parental care in order to protect them. So you can think of an example being like elephants. Elephants do not have very many babies. It's usually one, occasionally two at a time, but there's a lot of energy that is invested into caring for them and protecting them as they grow older. Now, throughout their life, they are usually going to reproduce many times. Even though they don't have very many offspring when they reproduce, they're still able to do it many times, mostly based on the fact that they tend to live longer. And so they still can have those occasional offspring. And this is going to encompass most mammals and birds. Now, when we look at the general trend of these organisms, they're going to have long lifespans, which means it takes them longer to get to sexual maturity. So what that means is that they have a low biotic potential, which leads to slower population growth rates. Now, what I mean by biotic potential is this is the maximum reproductive capacity of an organism under optimal environmental conditions. So like I said with the elephants, their maximum reproductive capacity is going to be one, maybe two offspring, even in the best of circumstances. And so this is going to lead to slow population growth over time. We're not going to see big spikes in these populations because it's going to take a little while to add the babies to grow this population over time. Now we're going to compare to R-selected species, which take the reproductive strategy of quantity instead of quality. And that is because they have many offspring. They just do not care for them much. What I mean by care is like protect them, watch over them, feed them, all of that. And so essentially, this is basically just where are these species putting in their energy? The K-selected species are going to put in energy to caring for their offspring. The R-selected species are going to put their energy into creating a lot of offspring. So it's just kind of a difference. Are you putting in all the energy to make them or to care for them? So one of the things with R-selected species, and this is not the case for all of them, but many of them only get to reproduce once in their life. So if we think of the common examples like insects or fish or plants, think of like salmon. They leave all their eggs and then they die. They only got to reproduce that one time. Or daffodils, they pop up, they have their flower, they do all of these hundreds of seeds, and then that was it. They died. However, there are some that can reproduce multiple times. It just is more common that we're seeing this with R-selected species than the K-selected species. And what we see with this is they have a shorter lifespan. Think of like a housefly that only lives for 24 hours. So this means that they are very quick to get to their sexual maturity. Houseflies, we're talking a matter of hours. If we're talking about some other organisms, it might be days or months, but we're usually not talking about years to sexual maturity when it comes to R-selected species. So what this means is that they have a high biotic potential. They can create a lot of offspring in optimal conditions. So it leads to high population growth. We can see populations spike when we are looking at our selected species because they can make a ton of offspring in a very short period of time. Now, the thing that I want you to be aware of, though, is that when we talk about K versus R selected species, it's a spectrum. We do have some organisms that are clearly just very R selected species, like oysters. They can produce 500 million offspring a year, and there is zero care whatsoever. They shoot it out into the ocean and hope it survives. Versus chimpanzees are going to be very much a K-selected species. They only have one baby every 5 years. But it is a spectrum. We do have some in here. For example, hares and rabbits, they lean, they're pretty much in the middle. And this is because they do have some parental care that goes into it. Like they come back and they feed their baby's milk. However, they have more offspring because there's a good chance that a lot of them are not going to survive. Additionally, if danger comes up, that mama rabbit will leave her babies to die very quickly because she knows she can have a few more in a month. Versus a chimpanzee will fight to the death to protect its one baby offspring potentially. So just be aware that it's not only R-selected species and only K-selected species. It is a spectrum that can be fallen into, and they can give different variations of how much parental care they are giving and how many offspring they're having. So when we have environmental disturbances, K-selected species and R-selected species are going to experience this differently. K-selected species, because they have a low biotic potential, it is going to be hard for their population to recover after a disturbance, such as a change in their environment. So they are more likely to be disrupted by environmental change or invasive species coming in and out competing them. Because it takes a long time for them to create more babies, it's going to take longer for that population to recover if we're not seeing much adaptation occurring. And they also get kind of this double whammy where the problem is because there is high potential or high parental care, this means that if the parent dies, we're basically going to assume that the baby's going to die too because it needs that parent to take care of it. So if we're having a disturbance, let's say a hurricane comes in and it kills the mom because a tree falls on the mom or something like that, the baby is then also basically going to die. So it's not just one organism that we're seeing dying here. It's going to be the parent and the offspring because that offspring for a long time is going to not be able to survive on its own. So disturbances are going to much more impact K-selected species. When we look at R-selected species, though, because they have high biotic potential, there's more rapid population recovery after disturbance. Let's say a disease comes in and wipes out half of your plants. Well, the other half can still have thousands of offspring, so they're going to do just fine. This is why no matter how many times you try to kill off or pluck up the dandelions in your yard, they're still going to keep coming back because they can make so many babies to recover from the fact that you just happen to pull a few of them away. And this means that our selected species are going to be much better suited for rapidly changing environmental conditions because their population can recover if even a small number of them are left over after a disturbance. And this also means that the low parental care, if a parent dies, it usually doesn't impact the offspring. If the dandelion have already spread all of their seeds, it doesn't matter if you go and you chop off one of those dandelions because the seeds are already out there and they don't need that mama dandelion to come and protect them and take care of them. Another category that we look at is how invasive species are going to be tied into all of this. So an invasive species is going to be a non-native species that spreads in a very destructive way. So for our selected species, they are not as impacted by invasive species because their population can grow quickly. If an invasive species comes and takes out part of their habitat and takes it up, you know what? They still can make thousands of babies with the small amount of area that they have left. In fact, when we're talking about invasive species, our selected species are more likely to be the invasive ones because they can have so many offspring, they can grow exponentially and spread if they're in a new environment that they can really thrive in. And because they have larger populations and faster generation time, we aren't waiting years for generations, we're waiting shorter periods. They have a much higher chance of adaptation and a lower chance of extinction. Comparing this to the K-selected species, they are usually outcompeted for resources by invasives, which I said usually are going to be the R-selected species. And this is because they just don't really have as much adaptation potential because they have populations that have slower growth. And so those adaptations are going to have less time to be able to be expressed and to spread throughout the population. So they're going to be more likely to, or less likely, to adapt and more likely to go extinct because they couldn't deal with the changes. So this is going to be our practice FRQ 3.2. The skill that you're going to be practicing is data analysis, where you describe patterns or trends in data. So I want you to look at the data of different types of shellfish. So we're going to look at a native species, the Unionid, and then zebra mussels. So what I want you to do is look at this chart, look at the data in them, and then for your practice FRQ, be aware that zebra mussels are an invasive species introduced into the Hudson River. So I want you to identify, based on this data, if zebra mussels are a K-selected species or an R-selected species, and then describe the relationship between zebra mussel and Unionid mussel population density in the Hudson River. So that's going to be your practice for FRQ 3.2. And those were your notes on 3.2 on K-selected species and R-selected species.